Hey guys, so I'm gonna break this up into two videos because I don't wanna just give it all in one whack, because I need you guys to try these problems on your own before you just resort to looking at my video and just copying it down. So yeah. Okay, so by Wednesday you'll have all the answers, obviously, but like you guys need to make sure that you are trying each of these problems and not just waiting for the answer, because that's not going to help you study. And you want to do good on this test because it does count towards your grade. Despite whatever other rumors you guys are hearing, it will count. And remember, last test that was put in, a lot of you guys, it dropped your score because the gradebook is set to automatically drop the lowest test score. So if you do that, you know, your grade, if you don't do good on this test, your grade might drop. And so please try, okay? It's not a hard test. As long as you guys have been doing the work, you've been asking questions, which some of you have, but a lot of you have not. So use this review to go over those things that you're not sure about. Okay, so we are using the graphs to find the limit. So that's just like the very first lesson. So on this one, I am finding the limit as x approaches -4. Let me zoom in on that. I'm going to do the odds today, and I'll do the evens in the next video. And I'm looking at this parabola, and we're approaching from the left and the right, x equals -4, which is around here. It's up here somewhere. I'm not exactly sure where. So I'm going to, the graph gives me a close estimate, so it's going to be somewhere between like a 9, well, not 9, maybe 12 to 15 somewhere. So let's see. So let's plug in the -4 for x. So -4 squared minus 3. -4 squared is 16. 16 minus 3 is 13. Okay, so the limit is 13, which makes sense because -4 would probably be around right here, and it would hit above 12 a little bit. Okay, but it's so small and it's so close, it's kind of hard to tell. So that's why I plugged it in, which you could do that. All right, this one, the limit as x approaches to, oh wait, that's even. Next one, number 3, I'm doing the odds, Mrs. Garcia, doing the odds. Limit as x approaches -2 of the absolute value of x plus 2 over x plus 2. Well, this one's really easy to tell. As x is approaching -2, -2 is right here. We have a point up above at 1, and we have a point down below at -1. So they're in two different places at the same time. We want to look for where they are at the same time at that number that they're approaching. So this one, the limit does not exist, D and E. Okay. Next odd one, another really easy one. As soon as you see it, you should know what the answer is because you see this oscillating up and down, up and down, up and down. It's bouncing. So automatically when you have something oscillating like that and it's approaching 0, D and E, the limit does not exist. The limit does not exist. Okay. For the next one, number 7, okay, we're looking at the limit as x approaches pi over 2 of the tangent of x. Okay, so pi over 2 is right here, and that's on a vertical asymptote. Well, as it approaches pi over 2 from the left and the right, it's going down to -infinity on the left, or sorry, on the right, and then up to positive infinity on the left from the going towards each other, towards pi over 2. So since it's going to infinity, top and bottom here, that means D and E. We can't track that. Okay, number 8. Oh, that's even, sorry, I keep forgetting. Okay, find the limit. Pull the lever, crunk. That's what that made me think of. Anyways, okay, so we're finding the limit as x approaches 4 of 1/2 x plus 3. So we're just going to plug in a 4 for x. So that'd be 1/2 times 4 plus 3. Half of 4 is 2. 2 plus 3 is 5. So the limit is 5. Number 11. Let's see, we have the limit as x approaches 2 of 5x minus 3 times 3x plus 5. Plug in a 2 for x. So we'll have 5 times 2 minus 3 times 3 times 2 plus 5. So 5 times 2 is 10. 10 minus 3 is 7. 3 times 2 is 6. 6 plus 5 is 11. 7 times 11 is 77. So the limit is 77. Yeah, you can get big numbers. We know that that can happen. Oh shoot, I didn't even. Oh well, so I'll do 11 for the next video then. Whoopsie. Next odd. Shoot, Mrs. Garcia. Okay, so limit as x approaches -2 of 5x plus 3 over 2x minus 9. So let's go ahead and plug in a -2 for the x. So I have 5 times -2 plus 3 over 2 times -2 plus 9. Oops, sorry. And 5 times -2 is -10. So I have -10 plus 3. Over 2 times -2 is -4, so -4 plus 9. -10 plus 3 is -7. -4 plus 9 is 5. So I think I messed up. I was like, that's not what I got on my answer. Oh, I changed this minus to a plus. My bad. I keep doing that. I woke up with a headache this morning. I'm like, Corona, is that you? But I haven't really been around anyone besides my family, so I don't think so. I shouldn't. That I might be dehydrated though. It was hot this weekend and I did a lot of things outside, so it's probably dehydration. But anyways, all right, my denominator was wrong. It should have been -4 minus 9, which is a -13. So I have a negative divided by a negative, which turns to a positive, so this is just positive 7 over 13. That's a 3, 13. Okay. All right, so that was number 13. Doing the evens. We are going to be finding the limit still. So these ones are kind of like the 11.2 lesson where we have to reduce it, just like we learned in the first semester of this class. And so we're going to go ahead and do it. So remember, we can't just plug in a 6, because if I plug in a 6 in the denominator, 6 squared is 36. 36 minus 36 is 0. And we can't do anything when there's a 0 in the denominator. So that's why we have to simplify this. So I'm going to draw a little arrow. This is the limit as, oh shoot, that's 14. I need to do 15. Ms. Garcia, we're doing the odds. So skip that one. I'll come back to the one on the next video. So, Violet and Lucas, I need you guys to be quiet, please. You hear that I am recording. All right, anyways, so I want to put this in standard form because that bothers me, but I'm going to kind of do it in a quick way. So remember when Mrs. Ardito was going over this lesson, because it's to the second power, I know it's going to have 2 factors. And I know that one of the factors has to cancel out. This one has to cancel out because if I plug in a -1 for x, 1 plus -1 is 0. So this factor of x plus 1 has to cancel. So that means that there has got to be an x plus 1 in the numerator. I'm just switching that around because I want it in standard form because that bothers me. Now up here, I need to be able to get a -3x squared, right? So what do I multiply by x to get -3x squared? Well, I have to multiply by a -3x because x times -3x is -3x squared. Okay, and then I know that 1 times -3x is -3x, but I need the middle term to be a -2x. So to make this -3x turn into a -2x, I have to add a positive x, which means I have to have a +1. Because then when I multiply x times 1, I get a positive x. And then 1 times -3x, so 1x minus 3x is -2x. And then 1 times 1 is 1. So I checked it. It works. Oops, that was supposed to be a check mark. And those cancel. So all I have left is a -3x plus 1. Can I zoom out? Yeah, I can. So I zoomed out a little bit too much. All right, so now I'm going to plug in the -1 for x, so -3 times -1 plus 1. And -3 times -1 is a positive 3. 3 plus 1 is 4. Oops. Okay, doing the odds. So I'm on number 17. Okay, and what color do I want to use now? Okay, green. So 17. All right, so we're gonna have to simplify this. And if you remember, we have fractions in the numerator. We have to get a common denominator in order to combine those fractions into one. So I need to multiply, see, this is a factor of x minus 8, and this is just a factor of 8. So this one needs a factor of 8, so I have to multiply it top and bottom. The other fraction needs a factor of x minus 8, so multiply that top and bottom. Okay, so when I rewrite this, it'll be the limit as x approaches 0 of, I'm going to have something all over x. In the numerator, the denominator of the numerator is going to have these two factors because that's the common denominator. I'm going to put the 8 out front, 8x minus 8. So you usually put the single term in the lead. And then in the numerator, I have 8 plus 1 times x minus 8. 1 times x minus 8 is just x minus 8. And I'm going to have a positive 8 and a negative 8. Those will cancel, so all I have is x. Okay. Then once you get here, what you do, you have a fraction divided by, well, make it a fraction. Dividing fractions is easy as pie. Flip the second and multiply. So when I do that, I'm going to be multiplying by the second fraction. It's reciprocal. The reciprocal of x over 1 is 1 over x. And now that's, we changed it, so I'm crossing it out to let us know, hey, we moved it. And now we have, these cancel. So now we have the limit as x approaches 0 of 1 over 8 times x minus 8. Okay, and now we could plug in the 0 for x. Excuse me, so I have 1 over 8 times 0 minus 8. 0 minus 8 is just negative 8. 8 times negative 8 is negative 64, so this fraction is negative 1/64. Okay, so that's the limit of 17. All right, skipping 18 on to 19. So in number 19, it says to find the slope at the specified point. So this is just our 11.3 notes. Okay, this is where we have to use the f of x plus h minus f of x all over h type thing. And I don't have a lot of room to work right here, so I'm going to do this on a separate sheet of paper because I don't want to cram it all in. And I'm hoping that you guys are trying not to do that too, because when you submit your work, that's hard for me to see, and I need to see your work, okay? Speaking of which, when it comes to the test, it is very important that you label every single problem on the test. Whether you know the answer from looking at it or not, you have to explain your answers on this test and on the final. If you don't, you will automatically get a 0 on that question, whether it was right or not. So please make sure that you do that, and I hope that you guys are listening to this because I haven't been getting a whole lot of views on these things. And I will be posting it on Google Classroom. I have been every day. Got to show your work, okay? We have to know that you're not cheating. So we have, and your work has to make sense. So yeah, we do look at that, by the way. All right, we have g of x equals 4 minus x squared at the specified point, negative 1, 3. Remember when it comes down to it, we don't need the y value of that specified point. We need the x value, okay? So let's do this. So I need to take the limit as h approaches 0 of, I need to plug in x plus h for that x. So I will have 4 minus x plus h quantity squared minus g of x, which is 4 minus x squared, and you have to put it in parentheses because you're going to have to distribute that minus sign all over h. Okay, all right, so from here we just have to clean it up some. So I'm going to go down to the next line, and I know that x plus h quantity squared is x plus h times x plus h, and that multiplies out to x squared plus 2xh plus h squared. You should have that memorized by now. You've done it so much. Okay, but I'm going to have to distribute this negative to it. So I'm going to rewrite this. The limit as h approaches 0, I know that this is all over h. And so I have a 4. And then negative times x squared is negative x squared. Negative times 2xh is negative 2xh. Negative times h squared is negative h squared. And then I also have to distribute this negative. So negative times 4 is negative 4. negative times negative x squared is a positive x squared. And now we can go through and cancel stuff out and get a little cancel happy. So I have positive 4, negative 4, negative x squared and positive x squared, and then I'm down to this. Okay, so I have the limit as h approaches 0 of negative 2xh minus h squared all over h. Okay, and I need to get that h in the denominator to cancel, because if I plug in a 0 right now, it makes the denominator 0, and I can't do anything with that. So now let's go ahead and factor out an h, because it looks like they all have an h in common. We could pull a Mrs. Ardito and be like, well, let's cancel out all the h's in common. So it's got to be all or nothing, right? So this h cancels with this and one of these. So now we're down to negative 2x minus an h to the first all over 1. So I don't need to put the over 1 part. Okay, give me a second. I'm almost done, okay? All right, so now we could plug in some things. We had this point up here, so we're going to plug in that x value, and then we have h approaching 0. So we're going to plug in 0 for h and negative 1 for x. So that'll be negative 2 times negative 1 minus 0. Well, double negative turns to a positive, so this is a slope of 2. Okay, so 19 is 2. Okay, back to the page. Now we're finding the derivative, which is just a fancy way of finding the slope. It just sounds so much more sophisticated and like you're really smart because you're using the word derivative. Anyways, so let's look at 21. Now 21 is really easy, so I'm going to do it on this sheet. Remember, f of x is the same as y, so this is y equals 5. Y equals a number is a horizontal line, and horizontal lines have no slope. So the slope equals 0, which means the derivative is 0. Okay? For these ones, remember these on IXL, how easy those were? All the linear ones were super easy. It's pretty much what the slope was. Okay? 22, I'm not going to do because it's even. It's obviously not linear because it's to the second power. Okay, so you'll have to do the whole f of x plus h minus f of x all over h thing, just like we did in number 19 to get that one. This one, 23, is going to be a little bit longer, so I'm going to use that separate sheet of paper again. So 23 is f of t equals the square root of t plus 5. And we're trying to find the derivative. Okay. All right, so let's go for it. Now we're not plugging in a number for t this time. We are just finding the limit as h approaches 0 of f of t plus h minus f of t all over h. We just want the equation that we would plug that x value into. Okay. All right, so we're finding the derivative. That's what that is. I'm going to need to plug in a t plus h for the t, so that would be square root of t plus h plus 5. And then I have to subtract the original function, so subtract the square root of t plus 5 all over h. And when we have something like this, we have to multiply by the conjugate. So that means I have to multiply top and bottom by the square root of t plus h plus 5 plus the square root of t plus 5. Okay? Same stuff except for the plus in the middle. This is the only sign that changes. This one has a minus, so this one has to have a plus. Because conjugates, when you multiply them together, the middle terms cancel. And then whatever we do to the top, we have to do to the bottom. So square root, oops, that's supposed to be an h. T plus h plus 5 plus square root of t plus 5. And remember, in the denominator, leave the junk in the trunk. Do not distribute it out. Don't try to simplify it further. Leave it like that, okay? All right, so I'm going to have the limit as h approaches 0 of, let's see, when I multiply these two together, radical times itself, the radical goes away, so the t plus h plus 5 gets to come out. Square root of t plus h plus 5 times square root of t plus 5 is the positive version, minus square root of t plus 5 times square root of t plus h plus 5 is the negative version, so those are going to cancel. And then negative square root of t plus 5 times positive square root of t plus 5 is negative, the t plus 5 gets to come out. But I'm putting it in parentheses because we're going to have to distribute that minus sign all over h times the square root of t plus h plus 5 plus the square root of t plus 5. Remember to leave the junk in the trunk. Okay, so when that negative sign gets distributed, that means that the t is negative and the 5 is negative. So these t's will cancel, the 5's will cancel. All we'll have left is h over h times that. And you know what? The h's are going to cancel. So I'm not going to rewrite it again because then it'll be real quick before I have to rewrite it yet again. So being a little bit lazy, but this one's a long problem. So the limit as h approaches 0, now we have 1, because everything canceled, over the square root of t plus h plus 5 plus the square root of t plus 5. Okay, well now we have to plug in the 0 for the h. So if I have a 0 there for h, it'll just be t plus 5 under that radical. So it's just 1 over the square root of t plus 5 plus the square root of t plus 5. So because these radicals have the same stuff in them, they're like terms. 1 square root of t plus 5 plus 1 square root of t plus 5 is 2 square root of t plus 5. And you can leave your answer like that. Okay, so that was 23. On to 25, which has to do with the latest lesson that we just did, 11.4, the one from Monday. So I'm going to do number 25. It's the limit as x approaches negative infinity. We're finding if the limit exists. Remember, 11.4 had to do with limits of infinity. So when we're looking at limits of infinity, we're looking at end behavior. We're looking at, in this case, towards negative infinity, so towards the left side of the graph. So we have to look at the degrees, and the degree of the numerator is a 1. The degree of the denominator is a 2. Okay, so the bottom is bigger. So we got a big bottom. You guys remember what that means? It was only yesterday. The big bottom means that we're going to, someone's sitting on the x-axis. So it is equals 0. Okay, that was the rule from last semester. That you didn't even know you were doing calculus, but you were. Isn't that cool? It's just taking what we've learned and really understanding what it means, okay? And how to apply it to stuff. All right, 26 is even, so I don't know why I was gonna do that. All right, so that's all the odds. This was 22 minutes, not bad. All right, so join me tomorrow for a look at the evens, and what you're gonna do is do corrections on your reviews. And then all together, when you are done doing your initial, basically your rough draft, and then your corrections, you're gonna turn in all that work. Make sure it's labeled and neat. It's probably gonna be a few pages, so if you have the Notes app on your phone, that's a great way. It keeps it in color, it makes it really easy for me to see, and it basically, you're uploading one PDF and it has all your pictures in there as a PDF. So if you can do that, that would be fantastic. There's a couple of you that haven't been doing that, but there are some of you that switched to that, and it really helps me out, and it actually makes it easier on you too. And then you have it in your phone, and you can delete it if you want, but some of these you might want to keep for next year, just saying. All right, guys, so that's it, and I will see you in my next video.